STEM Teachers NYC is a nonprofit group. It's a teacher group run by teachers, for teachers, about teaching. We do workshops for other teachers to help them reach excellence in science teaching. Today we're going to have a lab on pushing and pulling. Our students' conceptions are ideas about force and motion.
We were looking at how to start talking about the concept of force at all different age groups.
And particularly to have activities that they can have the students do to experience some of these ideas for themselves.
We were given 7 basic objects. Spring that was really tightly coiled, a loose spring, these brushes, sandpaper, a wooden block, things like that, and the task was to use any of the 2 objects together and write about how the forces that come into play when they're interacting.
I'm not pulling on the block, but it doesn't feel like I'm pushing on it either.
It's the biggest magic trick in science, right? It's like no strings attached, right?
That seems kind of like a wacky idea, right? How do you know that it's the Earth that's pulling on this?
That is a wacky idea at the elementary level anyway.
Why is it that when you stretch the spring, it pulls back on you?
It really made me think. It provides me with examples of models that I could use with my kids, experiments that I could use with my kids, really easy to incorporate into my classroom. And then we had to write it on a whiteboard and describe what 2 objects we had, what were the forces.
Having those definitions and agreed upon ideas of how forces work in hand, we were then able to proceed to a rotation sort of stations activity. One station dealing with an experience that would help students to describe Newton's first law and how it relates to the motion of a bowling ball when it's hit with a mallet or a broom.
It was fun to do, but it was also nice because the facilitator of the program was right there with me and was asking me the exact questions that I imagine a good teacher would be asking a student. I felt like I was being taken care of and I was learning exactly what I was supposed to be learning in that moment.
Then another station where students looked at 2 objects interacting with each other. Lots of different materials at that station for taking different measurements and setting up different situations.
Yeah, no matter what we did, the force always stayed the same.
To figure out, is it ever possible for an object to push a second object harder than the second object pushes the first object?
They're just glorified bathroom scales. So in here, one kid could push, the other kid could push, and then they could see. There's the inherent competitiveness between kids, and then they find out it's always tied.
Back when I was a student, physics was really hard for me. I used to teach biology and my degree's in biology, but they needed an 8th grade teacher this year, and so I was kind of put into this physics position without really having much background knowledge, and I know that I need more exposure, and so anyone can learn from this, and just from today you can very easily incorporate it into your classrooms.